We now discuss the solution of a problem from the section Permutations and Combinations. It is on counting and it uses the principle of inclusion and exclusion. This question has appeared in the joint entrance examination main held on 24th June 2022 in the second shift. The given problem is the sum of all the elements of the set consisting of alpha belongs to the set consisting of 1, 2, 3 up to 100 such that the HCF highest common factor of alpha comma 24 is equal to 1 is. So we have to find the sum of all the elements of the set alpha belongs to the set consisting of 1 to 100 such that the GCD of alpha comma 24 is 1. This is our given problem. We now discuss the solution of the problem in detail. We denote the set consisting of 1 to 100 as U. So for our purpose, this is the universal set, and alpha belongs to U. Let X be a subset of U, then S of X denotes the sum of the elements of X. Now we have 24 and whose prime factorization is 2 cube into 3 and HCF of alpha comma 24 is equal to 1, that is the GCD of alpha comma 24 is 1 if and only if alpha is not a multiple of 2 or alpha is not a multiple of 3. Let A be the set consisting of all those alpha belongs to U such that alpha is a multiple of 2. And similarly, we take B as the set consisting of alpha belongs to U. Alpha is a multiple of 3. Alpha is a multiple of 3. So here in A, alpha is a multiple of 2. Now, the sum of the elements in this given set, that is set consisting alpha belongs to set consisting of 1 to 100 such that HCF is alpha, HCF of alpha comma 24 is 1 is given by, that is equal to the sum of the elements in the set alpha belongs to U where alpha is not a multiple of 2 or alpha is not a multiple of 3. That is written as S of U. That means from the sum of all the elements of the set U minus subtract all those elements, sum of all those elements which is multiple of A union B. A union B means multiple of 2 and multiple of 3. Subtract because it is not a multiple of 2 or not a multiple of 3. Therefore, we subtract. And that will be equal to S of U is equal to minus the set consisting the minus S of A in brackets sum of the elements in A, that is sum of the elements which are the multiples of 2, S of B, that is the sum of the elements which are the multiple of 3 minus the S of A intersection B, that is sum of all those elements which are multiples of 2 and 3, that is 6. So thus we have derived this one, S of U minus in brackets S of A plus S of B minus S of A intersection B. So we will now compute these things and we get the answer. So this S of A union B is written in brackets S of A plus S of B minus S of A intersection B, where we have used the principle of inclusion and exclusion, and that is a counting principle. Okay, this is what we have derived in the last slide. Now S of U is the set consisting of 1 to 100. S of that means the sum of the elements of U, that is 1 plus 2 plus 3 plus 100, that is the sum of the first 100 natural numbers, that is n into n plus 1 by 2, where n is 100. Substitute, we'll get 5050. A is the set of all those elements in U which are multiples of 2, that is 2, 4, 6 up to 100. B is the set of all those elements of U which are multiple of multiples of 3, that is the set consisting of 3, 6, 9 and 99 up to 99. So A intersection B is the set of all those elements in U which is a multiple of both 2 and 3, that is all those elements in U which are multiples of 6, that is the set consisting of 6, 12, 18 up to 96. Agreed. S of A will be equal to the sum of all those elements in A, that is 2 plus 4 plus 6 plus 100. Take 2 common, you will get 1 plus 2 plus 3 up to 50. 2 into the sum of the first 50 natural numbers, that is 50 into 51 by 2, n into n plus 1 by 2, where n is 50. The answer is 2550. S of B, similarly 3 plus 6 plus 9 plus 99. So 3 taken common, the sum of the first 33 natural numbers, that is 3 into n plus 1 by 2, where n is 33, and the answer is 1683. S of A intersection B is the sum of the elements in A intersection B, that is 6 plus 12 plus 18 up to 96. 6, take 6 common, that is the sum of the first 16 natural numbers, 6 into n plus 1 by 2, where n is 16, and simplified you will get 816. Now we are ready. So the sum of all those elements in 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 the set 1 to 100, such that the HCF of alpha comma 24 is 1, is, we have derived the formula S of U is equal to minus in the brackets S of A plus S of B minus S of A intersection B. So S of U is 5050 minus in brackets S of A 2550 plus S of B 1683 minus S of A intersection B 816. So this is all in brackets. So simplify, we will get 1633. So that's our answer. Our answer to this question is 1633, and this is a question which uses a counting principle called the principle of inclusion and exclusion. I am sure that you have understood the solution of this problem, and this is the second question on counting that is appearing in this paper. And I wish you all the best. Thank you.